Last day we were studying about velocity, acceleration and speed. I told you what is the difference between them. Forget not, even though the displacement is zero, there are some cases that the distance may not be zero but the displacement will come to zero. That means if the initial point and the final point are still the same, even after traveling a lot of distance, the displacement comes to zero. Likewise, acceleration, it also becomes zero, even though there is a velocity. That means even though something is moving, it happens that acceleration can be zero. Where and how? What was acceleration? The difference in velocity. The change in velocity by time is what we call acceleration. So if there is no change in velocity, means if something is moving in a constant velocity, we will say that there is no change in velocity. So there we can say, as there is no change in velocity, there will be no acceleration. So acceleration means it should increase or decrease. The velocity should be continuously increasing or it should be decreasing. Okay, let us come to the new topic. And here today we are going to study about some graphical representations regarding motions. There are three equations regarding the motions. The one is v is equal to u plus at. Second one s is equal to ut plus half at square. And third one v square is equal to u square plus 2as. And in this class, we are going to study how to derive these three equations in graphical representation method. These three are very important things, and now I am going to teach you what are the terms. Let me just introduce the terms. If some object, if a particular object, it is traveling or it is moving somewhere. So it possesses a velocity, right? So the starting velocity is what we call the initial velocity. Initial means starting. So if anything is moving, we will say that there will be a starting velocity. And that is what we call u. That is what we call u. And when it comes to a final velocity, means when it's reaching in a particular, means if it is moving after 5 seconds, we want to know the second velocity. So the final velocity is what we call the v. That is what we call small letter v. So what is u? That is the initial velocity. V is the final velocity. And the time difference from the initial velocity to the final velocity, the time taken for any object to change its velocity is what we represent here as t. And s is the displacement. The total distance between the first position and the final position, or the initial position and the final position, is what we call S. Clear? So now we are going to derive the equation from this one. So just focus on the graph. So here, a particular object, I have drawn here a graph. A particular object is moving from the position A to the position B. Okay, from something is moving like this. I have drawn to a upper part like this. That means it is frequently changing. The velocity is changing. Means if I was drawing like this, we can say it's having a constant velocity. But here, as I drawn here, it's very clear that the velocity changes from A to B. And this point A, see here, it is not at zero. It is having a particular, when the time is zero, means this is what we call the time. Means this axis we will write the time, and in this axis we are representing the velocity. Normally, in everything, whenever we are studying physics, normally every time we will be representing the time along the x-axis only, along the x-axis. So here, even when the time is zero, acceleration is not zero, the velocity is not zero, right? It's having a particular velocity. And this velocity means from O to A, the distance is what we call u. And I told you what is u? That is the initial velocity. So this is the initial velocity. And this object was moving and now it reached the position B. And now the velocity, this much velocity, means this much velocity. And this velocity is what we call v. That is what we call the final velocity. So कोई भी एक चीज A से B तक जाने के लिए कितना time लिया है? How much time it took to travel from A to B, and that is what we represent as t. And now just to do some mathematical calculations, I have drawn here some perpendiculars. That means BC. You can see here BC is a perpendicular. Here AD is also perpendicular. So AD will be equal to OC because here you can see there is a rectangle. Clear? So these things are clear. This is what we have to talk about this. So now let us come to this one. See, I am defining about the graph. Let an object having its initial velocity u, moves from the position A to the position B, so that the final velocity will be v. And the time taken for that object to travel from A to B is what we call t seconds. Okay, that is t seconds. This much is there. And now let us find for the equation acceleration. Acceleration is equal to, we already know, is change in velocity divided by time. Last class I told you about this one. So this is the original equation to find the acceleration of any moving object. But when we are considering about a graph, normally if you want to find the acceleration of this particular object, we have to find the slope of this AP. In mathematics, I think you have studied about slopes. So here, if you want to find the slope, so normally this acceleration we have to find, that is the slope of AB, because it's a graph. That's why we are doing, it's a slope of AB. Slope of AB means whenever you want to find a slope of a particular thing, for example, something is inclined like this. If you want to find the slope of this one, this particular straight distance divided by this horizontal distance, that is what we call the slope. So here we can say it is BD by AD. BD is the horizontal vertical. See, it is vertical distance, and this is the horizontal distance. BD by AD. And see, come to the figure. What about BD? We can say this BD means it is total this BC minus DC, right? BD कितना होता है? इतनी BD जो है इतना ही है, तो इसका मतलब क्या है? वो पूरा BC minus DC होगा. So I am writing it instead of BD. I am writing BD. What will be BD? BD is equal to BC minus DC divided by what is AD? AD itself. That is equal to, see here, what is BC? B से सीख कर इसको क्या करता है? फाइनल वेलोसिटी B करता है. So BC का जगह क्या लिख सकता है? B लिख सकता है. माइनस व्हाट अबाउट DC? DC कुछ भी नहीं दिया इधर, लेकिन ये देखिए ये दोनों बराबर ही ना होगा. ये दोनों बराबर होगा because these two are the opposite sides of a rectangle. You can see here this OADC is a rectangle. So how much is DC? That much will be OA also. So already we know what is OA. It is U. If OA is U, this will be also U. So instead of DC, I am writing here U divided by what about AD? Here AD nothing is given, but as I told you right now, this is equal to OC. So we can say OC is already T, so this will be also T. So instead of AD, I am writing here T. So what is this one? This was the acceleration A, right? This was the acceleration A. So A is equal to V minus U by T. If you are cross multiplying, what you will get? AT is equal to V minus U. So if you are bringing this U to this side and keeping the V from this equation, you will get V is equal to U plus AT. This is the first equation of motion. Clear? So now, right now we have proved the first derivation, V is equal to U plus AT. Coming to the second derivation, same figure, same thing. Here you have to find the total displacement. Displacement happens. So from A to B, how much distance it traveled? What is the total displacement happen? If you want to find the displacement from a graph, how to find that one means the total area below the graph. The total area below the graph is what we call the total distance. Means इधर से इधर तक पूरा का पूरा जितना distance है, इतना distance. Means this much total distance is what we call. This area is what we call the distance. So finding the area of this one, we can say distance traveled S is equal to, or the displacement S is equal to, we can say area of OABC. OABC, this distance. So from that figure, it is very clear. See here, this OABC, I can write like this, that is equal to area of ADB plus area of OABC. This much total things. This figure, I made it into two figures. This is one triangle, you can see here. This much area is one triangle, right? And this one is one rectangle. So this triangle's area plus rectangle's area will be total area of that particular part. So normally I have substituted like this. Instead of finding the total area of this particular thing, I just splitted them like this. Area of a triangle plus area of a rectangle. Now, what is the area of a triangle? It is half into base into height. So here this is the triangle, half into base into height. This is the base, that is AD, into what is the height? It is BD. Plus here area of a rectangle. Area of rectangle is length into breadth. Here the length is OC into, here the breadth is OA. So OC into OA, I am taking like this. That is equal to half into what is the AD? Already we have mentioned in the previous proof. AD is the time. AD means that is the time itself. So instead of AD, I am writing here T into what is BD? BD will be BC minus DC. We already mentioned this BC minus BD. So BD क्या लिख सकता है? BC minus DC plus what is OC? OC is the time into what is OA? OA is the initial velocity U. Again here we have to substitute half into T into what is BC? BC is U, BC is V, V minus DC is, that is your U, V minus U plus here together I am writing it as UT, right? Now what is V minus U from this equation? This one we already proved, so I am bringing that here. See, we have V is equal to U plus AT. If I am bringing this U to this side, what will happen? V, this plus U will become minus U, V minus U is equal to AT हो जाएगा. So V minus U का जगह क्या लिख सकता है? AT लिख सकता है. So I am substituting here in this one. That's equal to half into, here there is one T into V minus U का जगह AT. AT plus UT. That's equal to half, here together we can say AT square plus UT. This is your S. So normally we will say S is equal to UT plus half AT square. That is your second derivation. Okay. Now let's come to the third derivation about this one. Same thing, just as of second, starting is same, distance traveled is equal to area of OA BC. And now see it, what about OA BC? That is what we call the area of trapezium OABC, right? That's a trapezium. See, OABC is a trapezium. How it comes to be a trapezium? What is a trapezium? Trapezium is a quadrilateral which is having one pair of opposite sides which are parallel. If one pair of opposite sides are parallel, and that typical type of quadrilateral is what we call a trapezium. So here you can see this OA and this BC, they are parallel to each other. So normally here we can say that this is a trapezium. So here, if you want to find the trapezium's area, if you want to find the area of this trapezium, the answer is over. We want to find the area of the area beneath the face of AB. So here you have to find the area of the trapezium. How to find the area of the trapezium? What's the equation? Area of a trapezium means that is equal to, what is that? What is the area of trapezium? Area of trapezium means half into sum of the parallel sides into height. So here that is equal to half into, what is the sum of the parallel sides? What is the parallel sides? OA is the one parallel side plus another parallel side is BC. OA plus BC into what is the height? This distance, that is OC. Because this will be the height. Actually, the height of a trapezium really, it means that the distance between the parallel sides. It's not this distance. The distance between the parallel sides is what we regard as the height of a trapezium. Forget not. That's why I took it OC, or else I have to take this one. So here it is OC, that is equal to, again, here it is S, right? We are starting with S. Half into, what is the OA? That is the U. Plus what is the BC? BC is the final velocity V. Into what is the OC? OC is T. That is equal to half into U plus V into C. From the first equation, I'm coming to the first equation, we already have V is equal to U plus AT. I'm bringing like this. That means AT is equal to V minus U, right? AT is equal to V minus U. From this one, T is equal to V minus U by, if you're bringing this A to here, it will become like this. So T is equal to V minus U by A. So instead of T, I can write this, I can substitute the value V minus U by A. Instead of this T, I substitute the value. So here, that is equal to half into U plus V into V minus U. That means here, I can write this as V plus U. Because U plus V and V plus U, both of them are same. Here V minus U by A. that's equal to 1 by 2 and a I am bringing together. What is u plus v into u minus v? That is v square minus u square. By the identical formula, a plus b into a minus b is a square minus b square. So similar like that, v plus u into v minus u, we can write v square minus u square. This is yes. If you are cross multiplying, what you will get? 2as. This 2a will come here. 2as is equal to v square minus u square. Or if you want to find the equation of v square, we can write v square is equal to u square plus 2as. This is the third equation of motion. So these three equations are very important regarding the motion. And why we are studying this equation and where we are using this equation is very important. Just understand. If normally when we are doing some numerical problems, inside the numerical problem, if the initial velocity and the final velocity at the time are given, you have to use this one. Means initial velocity is given, final velocity is given, you have to find the acceleration or you have to find the time. So at the time you have to check which equation, in which equation u is given, in which equation v is given, in which equation t is given. Means from that mathematical calculation you can come to the conclusion that which equation you have to take. For example, if you want to find in an equation nothing is given regarding a time. टाइम के बारे में ना कुछ दिया है, टाइम के बारे में ढूंढने के लिए ना कुछ पूछा है, तो उस वक्त क्या करना है? जो इक्वेशन में टाइम नहीं है वो इक्वेशन है. You have to take an equation where time is not at all mentioned. So which is the equation where time is not at all mentioned? In the first equation time is mentioned. In the second equation also time is mentioned 2 times. So see the second equation, the time is not mentioned. So wisely you have to choose the equations accordingly. Means in the problems inside your numericals, wherever they are asking you questions, first of all prepare a chart, what is given and what is to be found. And by using that typical data, you have to come to the conclusion which equation you have to take. So these are the important equations regarding the motion of any object.